Tonight, it's just you and me. For the next 10 minutes, I'm going to take you somewhere no human has ever been. A world that looks like paradise, but would kill you in less than 30 seconds. If you stood on this planet, you wouldn't drown, you wouldn't freeze, you wouldn't burn, you would be shredded by sideways shards of molten glass, moving 7 times faster than the speed of sound. This is HD 189733B. You don't see the storm at first. You hear it. A shriek across the horizon. Not thunder, not wind. Something sharper. The sky above you glows electric blue. Calm. And then the first shard hits. It doesn't splash, it slices. The rain is not water, it's glass. And it's moving faster than a bullet. Welcome to HD 189733B, the planet where it rains sideways, at 5,400 miles per hour. From orbit, this world is stunning, a deep, rich azure blue. It's located about 64 light-years away from Earth. It was discovered in 2005 using the transit method, detected as it passed in front of its star, slightly dimming its light. Its mass? Roughly 13% more massive than Jupiter. Its diameter? Slightly larger. But its environment? Nothing like our solar system. On its day side, temperatures soar between 1,700 and 2,000 degrees Fahrenheit. Hot enough to melt silver. Hot enough to vaporize rock. Hot enough to turn minerals into atmosphere. And that's where the glass begins. The atmosphere of this planet is saturated with silicate particles. Silicates. These are not just trace elements. They are a fundamental component of the air itself. Specifically, scientists believe these are minerals like forsterite and olivine, rich in magnesium and silicon. On Earth, we know these compounds as the building blocks of sand, rock, and glass. But here, they play a much more sinister role. The planet's day side is locked facing its star, creating a permanent furnace where temperatures soar to over 1,000 degrees Celsius. The heat is so extreme that these solid rock-forming materials vaporize. They sublimate directly into a gas, becoming part of the atmosphere itself. This superheated silicate vapor doesn't stay put. It's swept up in a powerful atmospheric conveyor belt, rising and flowing toward the cooler upper layers and the planet's dark side. As it travels, it cools. It condenses, but it does not form gentle water droplets like the rain on Earth. It forms molten glass droplets. As they cool further, they solidify into tiny shards, microscopic blades, razor sharp, and then gravity pulls them downward. But they don't fall gently. They don't even fall. They are weaponized by the atmosphere. The massive temperature difference between the day and night sides drives unimaginable winds. Winds on this planet reach up to 5,400 miles per hour. That's 7 times the speed of sound, faster than a fighter jet, faster than most bullets. These winds don't let the rain fall vertically. They rip it sideways, accelerating the glass shards into a lethal horizontal barrage. Imagine a global sandblaster. Now replace the sand with microscopic blades of molten glass, fired at supersonic speeds. NASA scientists have described the effect as death by 1,000 cuts. Not because you would bleed, but because every exposed surface would be shredded instantly. Your suit would erode, metal would scar, even reinforced glass would fracture and fail. Anything solid would be stripped away, layer by layer, by this relentless supersonic abrasion. The storm never truly stops. There is no calm, no eye of the storm. This isn't weather. This is a permanent planetary condition. An eternal global tempest of flying glass. Let's immerse ourselves sensor by sensor in this impossible world. Let's experience what it would truly be like to stand on a planet where it rains glass sideways. First, sight. The sky is an intense, deep cobalt blue. Not the gentle blue of Earth, born from nitrogen and oxygen scattering sunlight. This hue is alien, created by something far stranger. Microscopic silicate particles suspended in the atmosphere, scattering the light of the star that burns large and white-hot overhead. The horizon shimmers under a crushing heat distortion, a constant mirage dancing at the edge of perception. Instead of fluffy water ice clouds, you see streaks, long horizontal veils of silicate mist. These are the seeds of the glass rain, racing across the atmosphere at thousands of miles per hour. Lightning flickers deep within these metallic clouds, a silent, furious discharge of energy. Look down. There are no oceans, no land, only churning gas layers stretching thousands of miles deep, a bottomless abyss of pressure and heat. Now, sound. The wind does not howl. It screams, a physical manifestation of the extreme temperature difference between the planet's day and night sides. This creates a continuous sonic boom, a tearing, ripping roar that never fades, the sound of an atmosphere at war with itself. The impact of glass particles would add another layer to this hellscape of sound. Not a patter, but infinite high-speed impacts. A percussive, shredding noise, like standing inside a jet engine filled with sand. Smell. If you could somehow smell through a protective suit, you'd detect hydrogen sulfide. The unmistakable scent of rotten eggs, sulfuric, choking. It's a pungent reminder that the very chemistry of this world is hostile to life as we know it. Touch. Step outside without protection. You wouldn't feel the 1,000-degree heat first. You'd feel pressure and velocity. The atmosphere would crush you instantly, a force hundreds of times greater than Earth's. Your body would experience forces it was never designed to withstand. Then, the slicing impacts of the glass rain, sandblasting you at supersonic speeds. Then, catastrophic, instantaneous failure. And finally, taste. The air itself would be metallic, bitter, an acidic vapor that would dissolve your tongue on contact. But you wouldn't live long enough to describe it. This is a world of terrible beauty, a place that can only be experienced from a great, great distance. If you landed here, on this beautiful but brutal world, what would you experience? Let's simulate it. Your spacecraft enters a tight, rapid orbit, skimming the upper atmosphere. The planet below is a mesmerizing deep cobalt blue. Almost immediately, violent turbulence shakes the hull. This isn't just atmospheric entry. It's a collision with a planet-wide weather system moving at unimaginable speeds. You descend toward the day side. Heat shields glow, struggling to dissipate the immense energy. Atmospheric friction rises far beyond design limits. Alarms scream as external temperatures soar past 1,000 degrees Celsius. Against all odds, you deploy. You step out. Your boots sink into nothing because there is no surface. This is a gas giant, an endless ocean of air. You're suspended in a crushing, dense atmosphere. Within seconds, winds moving at 2 kilometers per second seize your body, flinging you sideways. Then, the glass rain begins. Not water, but vaporized rock, silicate particles, condensing into sharp, solid projectiles. Your visor scratches instantly, turning opaque. The outer layer of your suit erodes under the supersonic abrasion, a relentless sandblasting at 7 times the speed of sound. Temperature climbs past survivable thresholds. The atmospheric pressure increases with every meter you fall, threatening to crush you. Your oxygen system fails, clogged and destroyed by the particulate infiltration. Total survival time? Likely less than 30 seconds. And that's with the most advanced technology imaginable. Without it, you wouldn't last a single breath. You would be simultaneously vaporized, shredded, and crushed in the blink of an eye. And yet, this violent world teaches us something powerful. We discovered its blue color by analyzing starlight filtering through its atmosphere. We detected silicates. We measured wind speeds by observing heat redistribution between its day and night sides. We identified hydrogen sulfide in its chemical signature. From 64 light-years away, we have never seen the glass fall, but physics tells us it must. This planet expands our understanding of atmospheric chemistry under extreme conditions. It challenges models of planetary formation, and it proves that beauty in space can be deceiving. Somewhere out there, beyond our sky, A blue planet spins under a screaming storm of molten glass. No oceans, no forests, no life, just beauty and violence woven together. And this is only one world among trillions. The universe is not just strange, it is savage and breathtaking. This was HD 189733b, the planet where it rains glass. Welcome to the strangest worlds in the cosmos. Thanks for watching Strange Scary Planets. Hit the sub and like button to join us in our next video. You can follow up on Instagram and TikTok Strange Scary Planets. Soft wind bed under an uplifting spacious swell. If this journey blew your mind, share it with someone who loves space. Hit like, subscribe, turn on notifications, follow us on Instagram, follow us on YouTube, Strange Scary Planets, for more cinematic explorations of the strangest planets.